Hello, class. So this will be the recorded lecture, again, in section 8.3, the last one. And this one's going to show you an example of using Cramer's rule on a three equation, three unknown system of linear equations. Out of all the ones that we have done, you will think that this is by far the most tedious. And I don't disagree. But the concept, again, of letting a computer being able to do this calculation is kind of nice. And number two is that this calculation is kind of nice in the sense that if you do end up getting answers that are fractions or decimals, it kind of takes the complicated fractional arithmetic out of the equation, because all you're doing is calculating a bunch of determinants. And doing these ratios are going to give you the fractions. So I'm going to do this example. I took it right out of the book. So here we go. So we're going to do this one here. And so here's the definition. And so in the 2 by 2, we had X and Y, and now we have X, Y, and Z. So we just have one extra determinants to do. But as you could see that when you do the dx, you replace the answer with the x column. When you do dy, you replace the answers with the y column, and you replace the answers with the z column when you do dz. So what we're going to do is walk through this calculation. And since I'm going to ask you to do it, I will do one for you as well. So misery loves company on this one. And so let me pull up the whiteboard and walk through this. So I wrote the equation up on the board. And so here is our D matrix. And our D matrix is the coefficients of all the variables. And so if we wanted to calculate this determinant, we could do, say, let's do, what did we do here? All in the book here. Okay, so basically they're doing 2 times A11, and then plus 1 times A12, and then plus minus 1 times A13. So we just have to calculate all these. So what I'd like to do is do it in one kind of big step to show you what I mean. So let's see how this works. So the first one is 2, all right? And so A11 would be minus 1 to the 1 plus 1 power, right? And that would that. And now we need M11. And so what we're going to do, let me get a different color here. So this would be 1 and 1. So what we're going to have here is 2, 4, minus 2, and minus 3. So that would be the first one. Okay. Next one would be plus the number 1. And now we're going to do 1, 2. So that would be minus 1 to the 1 plus 2 up here. And so now what do we cancel out? Well, again, we still cancel out row 1, but now what do? We cancel out column 2. So this would be determinant minus 1, 1, 4, and minus 3. Okay, see the tedious part of it, right? But it seems to go okay here. And then we'll do the last one, which is plus minus 1. And then now what do we want to cancel out? Well, we still want to cancel out row 1, but now we're going to cancel out column 3. So this would be minus 1 to the 1 plus 3. And then this would be minus 1, 2, 1, minus 2. So then you just have to calculate these determinants. So this would be 2. And this will give us a plus 1. And so what's this determinant? Well, I'm going to kind of run it out of room, so I'm just going to talk through it. So this would be -6 minus a -8. So that would be +2. And then this one would be 1, and then this would be -1. And what is this determinant? So this would be +3 minus 4. So that would be a -1. And then the last one is -1. And that would be a +1, right? Because -1 to the 4th power. And so what is the last one? Well, this would be +2 and -2. So this would be 0. So that turns out to be a decent number, right? So this would be 4 plus 1 plus 0 equals 5. So what do we end up with? Well, we know that our, let me just put it up here. Our D would be the number 5. Okay, so now we have the 3 variable determinants to calculate. So let's calculate dx. And so how do we do that? Well, you replace this row with the answer, because that's, I'm sorry, this column, and that is b with 3 minus 3 and 4. So again, if we do the same, it would be 3 times a11 plus 1 times a12, and then plus -1 times a13. There's no zeros anywhere, so I usually just pick the first row, and that's what the book did too. So let's calculate the dx. And I will just kind of walk through this step by step again. So the determinant x will be the 3, and then that would be -1 to the 1 plus 1. All right, and then if we, let's use a different color here, let's say green, we cancel these out. Again, we have 2, 4, -2, and -3. So that would be 3 times a11. And then the next one would be 1, right? Times -1 over 1 plus 2. There's where the sign changes. And so what is this? And so this would be, we would cancel out, again, row 1, but now column 2. So that would be -3, 4, 4, and -3. So the next one would be -1. And then -1 to the 1 plus 3. And then what's our last little 2 by 2 minor is 1, 3, right? So again, you cancel out row 1, but now we cancel out column 3, and you get -3, 2, 4, and -2. And again, let's do this calculation. So this would be, this goes to +1, so this would be 3. And what would this be? This would be -6, and then minus a -8, and so that would be +2. So just like we did before. So this one would be 1 times -1, right? Because that would be to the 3rd power. And so this would be -9 minus, or +9, -3 times -3 is +9 minus 12. So that would be, let's see. Okay, let me do this again. So -9 plus, not 12, 4 times 4 is 16. So if you add that together, that would be +7. So that is like, what am I doing wrong in my arithmetic? See what I mean by tedious? So here, the last one would be plus a -1, and then this would be to the 4th power. So that would be -1 and +1. So what would this last one be? This would be 6 minus 8, so that would be -2. So if we do this, you would get 6 plus 7, and then plus 2, and that would give us 15. So dx would give us 15. Okay, so now we have dx. So guess what's next? dy, right? So if we do dy, let's pick a different color here. Let's do orange, see what orange looks like, dy. So what we want to do is replace the y column with the answers, right? So if you do that, you replace it with 3, minus 3, and 4. And again, no zeros anywhere, so we might as well just pick the first row. And so in this case, you would put a 2 here. There's a change for a 3, and this would be a minus 1 again. So you walk through the same calculation again. So what is dy? So that would be 2, and then minus 1 to the 1 plus 1. See the pattern? And so in this case, let's use brown maybe. And so we cancel these out. Make sure I write it right. Minus 3, 4, 4, and minus 3. And so this would be plus. This would be 3 times, here we change the sign. This would be 1 plus 2. So you have an odd exponent. And so it would again, well, no. Come on, undo. There we go. So there we go. Row 1, column 2. So that would be minus 1, 4, 1, and 3. So the last one would be a minus 1 times a minus 1 to the 1 plus 3. And then what is our determinant? So we'll get rid of the third column this time, and you have minus 1, minus 3, 1, and 4. So again, it's tedious, right? So here we have 2, and then that would be a plus 1. And then if you do that determinant, which we've done before, that was minus 7, 9 minus 16, right? And this would be plus 3, and then this is minus 1. And if you do this determinant here, you would get minus 3 and oops, this is a minus here. See, I forgot that minus sign there. So this would be minus plus 3 minus 4, and that would be minus 1. Got to make sure I write these right. And then this last one here, this one's written right. You would end up with plus minus 1 times 1, because that would be to the 4th power. And then if you did this determinant, it'd be minus 1 plus 3, and that would be minus 1. So if you add all this together here, you would get, let's see, minus 14 plus 3 plus 1, and that would be minus 10. So dy equals minus 10. One more to go. So the last one will be the determinant for the z variable. So again, the same strategy. Get rid of the z column. I just put the column back together. And so let's put that and say pick. So again, that would be 3 minus 3 and 4. And so this would be 2, 1, and 3. So one last time, dz is the 2, right? Times minus 1 to the 1 plus 1. So that sign doesn't change. And so let's see what we have here. 2 minus 3 minus 2 and 4. And then this would be plus 1 times, here's where the sign changes, because you got an odd number up there. See what that minor looks like. So get rid of that. Oh no. Lost that number there. That should be a 1, right? Yeah. And so we get rid of column 2 this time. And we end up with -1, -3, and then 1, 4. And so almost there. So excited. I warned you this is the most tedious. And since I'm asking you to do it, I will do one of them with you. And so this time we'll get rid of this column. And we end up with -1, 2, 1, and -2. Finish this up. dz would be 2, and that would be times 1. And when you do this determinant, it'd be 8 minus 6, and so that would be 2. And then this would be +1 and -1. And when you do this determinant, it would be -5 plus 3. And so that would all, let's see, no, -4 plus 3. So that would be -1. And then the last one would be 3 times 1. And this looks like this is +2 and -2. So this determinant here would be 0. So this goes away. And it looks like we end up with 4 plus 1. And so dz would equal 5. So as a human being, is this the best way to do it? Absolutely not. But you'll see that determinants are good for other calculations as well. And this is obviously just an introduction. For anybody taking linear system analysis or linear algebra, you'll see that you'll be using matrices quite a bit. So it's good to get a little bit of feel for this. So final big drum roll, please. All right. What is x? Well, x is dx over d. And all that calculation, we end up with what? This is 5 over 5. And so x equals 1. What's y equal? dy over d. Whoops. I can't read my own writing up there. Let's start over. dx is 15. So that's 15 over 5. And that's 3. I don't know why I was looking at dz for that, but I actually did. This one would be -10, right, over 5. And so that would be -2. And the z variable would be dz over d. And that would be the 5 divided by 5. And you could see that would equal 1. So if we did it in the triplet form, it would look like that. And ipso facto. So that ends the recorded lecture for probably the most tedious calculation that we've done. Kind of left it to the end. But this is a calculation using Cramer's rule for a linear system of 3 by 3 equations.